All right, here's my poster of the synthesis of polystyrene block polymethyl methacrylate copolymer using ATRP. And starting with the background, I wanted to include some information about free radical polymerization and its limitations, such as it is difficult to control molecular weight. It generally has a high molecular weight yield. And here we employed atom transfer radical polymerization, ATRP, in this reaction to limit the number of growing chains in the reaction by balancing the reaction through a careful equilibrium of deactivation and activation of these growing chains. And I mentioned some applications of ATRP in protein detection, biopolymers, drug delivery, etc. In this reaction where we focused on ATRP, our goal was to make a copolymer with styrene and MMA. And we first started the first reaction with styrene, copper bromide as a metal complex, and PM-DITA as our ligand in a 1-to-1 stoichiometric ratio. And in the second reaction, we combined our styrene product with copper chloride and BIPI initiator in a 1-to-2 stoichiometric ratio. And when synthesizing these molecules, we had target molecular weights of 8,000 grams per mole of styrene and 10,000 grams per mole of PMMA. And right here is a schematic of the role of the halogen in ATRP and how it switches to end cap and terminate growing polymer chains. As far as our methods, part A of the experiment involved synthesizing that polystyrene chain to where it was stirred at 100 degrees Celsius for 100 minutes, and the reaction flask turned from a jade green color to a dark precipitate over the course of the experiment. And right here is a schematic of the reaction process. In part 2 of the experiment, we used our product from part A, but this time we used copper chloride, metal catalyst, and a BIPI ligand in a 1-to-1-to-2 stoichiometric ratio. And this was also stirred and heated for 100 minutes at 100 degrees Celsius. And once the reaction was complete, we poured it over Dowex, MSC, macroporous ion exchange resin, and basic alumina filter to remove excess catalyst and get our pure product. An important step of this part in both parts of the experiment actually is to purge the reaction flask using nitrogen. But in actuality, our group forgot to turn on the nitrogen when it was all set up. So that really prevented the progress of a reaction. But even though we got some yield, it could have been a lot more successful if we wouldn't have forgotten that step. And for the latter part of the methods, we had to characterize our polymer products to ensure completion of the reaction through gel permeation chromatography and proton NMR. And the NMR tubes were prepared with 5 grams of product, 0.5 grams of product in 0.7 mils of deuterated chloroform. For our results, we created a polystyrene calibration curve using the natural log of the intrinsic viscosity times the monomer concentration. And this created a calibration curve to where we could plug this into our Excel spreadsheet and therefore calculate our molecular weights and PDIs of each of the polymer products. And our GPC data was processed using the MagicPlot software to create Gaussian curves to fit our peaks. And if I zoom in right here, you can see the Gaussian peaks on the left for polystyrene and on the right for our diblock copolymer. And it was a little messy only because we had a lot of unreacted monomer due to the presence of oxygen contamination, because oxygen can prematurely terminate polymer chains to where we have a lot of unreacted monomer in our reaction flask. Additionally, here's our NMR spectra for the 2 polymers. And here on the left, we see our styrene peaks, and it is valid because around 7 ppm parts per million, we see those aromatic protons, but we do not see any presence of those in the right spectra with the polymethyl methacrylate present. We do see our evidence of an ester group around 3.5 to 2 parts per million, but there was no further evidence of polystyrene in our diblock copolymer spectra, unfortunately. As far as future work, we would intend to actually purge the reaction flask to eliminate any chance of oxygen contamination. But by furthering this experiment, we could try using different metal ligand complexes in the same ATRP reaction as this experiment to observe if the reaction could successfully produce the copolymer with the target molecular weight without actually reducing the molecular weight as the copolymer is synthesized, only because the molecular weight in our experiment resulted in something much lower, such as 3,800 grams per mole for styrene and 1,900 grams per mole of diblock copolymer when we expected 8,000 and 10,000 grams per mole. So thank you for listening.